Once again, welcome back, guys. I know it's warm out there. It's going to get warmer tomorrow and Friday. Friday is going to be the hottest day of August by the looks of it. So just hang in there. But after that, hopefully it starts cooling off. However, we have warm-up number 3 on the screen. Don't copy number 1, so go straight to part 2 and part 3. Work on those. And this time, I am going to be calling some of you to give me some answers. By now, we should be able to do these, yes? All right, so I'll give you some time for that. So let's get to work. All right, so you should be just about done, yes? Show of hands if you need more time. Okay, I'll give you one more minute. One more minute for number 3. I'm assuming you're finishing number 3, yes? Okay, so once again, for number 2, it says find the sum, difference, product, and quotient of negative 18 and 23, Michael Jordan. And number 3, it says find the sum, difference, product, and quotient of negative 7.5 and 2.3. So I'll give you a little bit more time for those two. Let's see what we got. Get us started, please, Lilith. Sum for negative 18 and 23, what'd you get? 5. That is correct. Difference, Aaron, what'd you get? Negative 41. That is correct. I'm going to change that color. Yes, negative 41. Seth, product, what'd you get?
Negative 414.
That is correct. I'm going to do the quotient just because some of you had like some questions on that. This is not 23 divided by 18, which is 1 point something. It's the other way around. 18 divided by 23. So whenever the first number is called, the first number is the one that is inside. Right, so that's why we're clarifying all those steps, right? So 18 divided by 23, so you can write this as a fraction, negative 18 over 23, and I'll take that answer. But if you did the division, 23 fits in there, let's see, into 180, is it 7 times? 7? So I'm just going to leave it as approximately negative 0.7 for right now. All right, let's go to the sum for the second pair. Ali, what'd you get? For the sum? Negative 5.2, that is correct. How about the difference? Roxmelly, what'd you get? Negative 9.8, that is correct. Let's see, how about Stephen, product? 17.25 negative, that is correct. And the quotient? About Mr. Q, yes, I'll do that one. So that is 7.5 divided by 2.3. That's going to fit in there how many times? 3 times. Subtract that 6, bring down to 0. So that is something like that, and it's a negative. Negative 3.2, and it continues going. Yes? Good practice, yes? All right, so today, the purpose of today, guys, today we're not going to log on to our Chromebooks or iPads because I want us to get through the entire session. And so like that, you guys can see the progression of how everything flows. Today's going to be the first day that we're going to finish up the lesson. And yeah, so first things first, here we go. What did we do first? Warm-up. Second thing, you need to copy the agenda right underneath your warm-up. So here's the agenda for today. Agenda for today, warm-up number 3. We just finished. The session is still on number sets and expressions. Today we're going to finish that. And for tonight, your home play is 6 problems on simplifying expressions. And at the end, we just adjourn. So once again, we start with a warm-up, copy the agenda right underneath. All right, so warm-up, agenda, what's next? Don't copy this. This, guys, those of you that are watching online, if you're absent, for those of you that are in sports, here it goes again. You need to go to my YouTube channel every time that you're absent. Watch the video lesson. In the video lesson, I'm going to include a code for Nearpod, and that's going to be the presentation that I'm going to be showing in class so you can follow along. Does that make sense? Yeah. All right. So for you guys that are here live with me, you don't need to copy that. For those that are watching the video, you do need to write that code and log into Nearpod and follow along while you watch the video. All right. With that said, the next thing that I asked for, we'll still need to quick reminder on materials. Make sure you get your stuff ready. Like I said, today we're going to get into a little bit into polynomials, and next week it's going to start getting a little bit more into the Algebra 2 course, and then from there we're going to get into the graphing, so that's why you need all these materials that I'm asking for, okay? Previous home play were these 8 problems. Get that in front of you, please. That's the next thing that I asked for in class. Now, I usually ask you to turn it in to me when I call you by row, or by taking a picture and submitting on Nearpod. But for today, for the sake of time, I want you to turn to your neighbor and check number 2 and number 5. Make sure that they got the correct answer for at least those 2. 2 and 5. All right. So, according to what I heard, most of you got it correct, which is good. That's just a review. I just wanted to make sure that you applied some of the stuff that we saw in the warm-up and you took it home. However, some of them might have been a little bit confusing. That's what we're going to be addressing today for the rest of the lesson. Okay? So for number 2, you should have gotten -2. And for number 5, you should have gotten 8x plus -3 or 8x minus 3. All right? We good? All right, so tonight's home play. Copy this, please. 6 problems. And I'll give you some time for that. Those of you watching the video, pause it. All right, so your home play once again, these 6 problems right here. Make sure you work those out. Today should be a piece of cake. If you had some problems last night, then maybe it's because we haven't finished the part that I'm going to cover today, okay? All right, so with that said, y'all ready? All right, let's get started. So here goes the flow of the lesson. We usually start with the objective, which we already started yesterday. So our objective for today, I can simplify algebraic expressions. Once again, I can simplify algebraic expressions. If I was to ask one of you what is the main idea or the main concept, so the question here, what is the concept for today? You would say what, Seth? Algebraic expressions, that is correct, because that's in green. And what are we doing with it, everyone? We're simplifying, okay? And I asked you to write that at the bottom left of your Cornell notes, and the algebraic expression term goes in the Frere model. We're going to fill that in towards the end. So we started off with expressions. And these, I said, we cannot solve. What can we do? We can do 3 things: translate, evaluate, and simplify. And I showed you that example yesterday. From there, I asked you to copy this behind the Cornell notes. Is that correct? Yes. And then from there, we got started with real numbers. And I said real numbers is broken into two sets, which is rational. Rationals can be written as fractions or decimals. Irrational cannot be written as fractions or decimals. Rationals, there's 3 subsets in there. And I said these are the 3 that we've been working with ever since you've been in elementary. Counting numbers, yes, remember those? From there, we add a 0 to the counting numbers. It becomes whole numbers. From there, we add the opposites to that set, and they become integers. So we have 0, all the positives, and all the negatives, and those are my integers. And then I showed you square root of 4. And I said square root of 4 is a real number, because what is square root of 4? 2, or negative 2 times negative 2 is also 4. From there, I gave you irrational numbers, and I showed you pi, which is 3.1415, and it keeps going. It doesn't stop. That cannot be written as a fraction. Square root of 2 cannot be written as a fraction. I'll talk about phi, which is the golden rule. You guys remember that? And then from there I talked about E. Okay? So today, I think I left off right there. Is that correct?
Yeah.
So today I'm going to cover the next set of numbers that we're going to start getting into for our Algebra 2 course, which is imaginary. So I want you to write this down. Square root of -16. All right? So, writing utensils down, look up to the screen. Here we go. I'm going to break it down because this is the most foundational way of looking at imaginary. Okay? Now, a way of thinking about it is this. Square roots, we know that the rule is a number times itself. How many times? Twice. A number times itself. So with that said, think of a number times itself that gives you -16. Just think about it. Don't say it. Think about it. And you're like, wait a minute. There's nothing times itself that gives us -16. Is that correct? Your brain wants to do -4 times 4, but no, it has to be the same number. So if there is none, that's why these numbers are known as imaginary. Or those of you that were with me in Frank Wright, what did I say? Imaginary. Remember that? You guys seen that? No? You guys don't watch SpongeBob? Okay. Never mind. However, we can rewrite this and simplify it. Pay attention, here it goes. Okay? And writing utensils down, pay attention please. I'll give you time to copy afterwards. Square root of -16 can be written as square root of -1 times 16. Do you agree with that so far? -1 times 16 is what? -16. Yeah, so far so good, yes? Why do I do that? Because now I can split it up into two square roots. Square root of -1 times square root of 16. You're like, aw, snap, I see what you did, Mr. Q. What is square root of 16? 4. So the only thing, so pay attention, the only thing that I need to know is what this is. From now on, whenever you end up with a square root of the -1, this is what we call I. For what? Imaginary. Anytime you end up with a square root of -1, it's what? Imaginary, or the letter I. Copy that, please. So, what is the one thing that you notice? That this square root has a what? Negative. So you might have a question in your noodle that says, well, what if it wasn't a negative, Mr. Q? What if it was only a positive? Well, where would it go? Then that means it has to go somewhere in these columns over here. Real number. So let's practice another one. Here we go. Let's do a square root -49. Let's do that one together. Ready? So to rewrite square root of -49, we can rewrite it as square root -1 times 49. So how can we rewrite this? Well, square root of -1 times square root of 49. So what is the one thing that we do know? Square root of 49, right? Which is what? 7. And what is square root of -1? I. That is correct, and that goes right there. You're like, oh, I got this, Q. Right? We got this. One more. Here we go. Copy this one. You do this one by yourself, but I don't want you to use all the process. I just want you to give me the answer. Ready? Square root -81. Don't say it out loud. Hopefully your brain already did all the heavy lifting. All right. Share with your neighbor what you got. Alright. Haley, what'd you get? 9I. Hands, have you got that? Yeah, we got this, yes? So just make a note at the end, guys. Make a note, and the note would be -1 will always be the square root. I'm sorry, my bad. I is always the square root of -1. Make a note for yourself, have that handy, and leave it there. Okay? And that's why we call those imaginary. All right. So now that we understand what real numbers look like, what imaginary numbers look like, I added one more component to that table. Is that correct? And that component is down here. Did everybody add that component down there? Yes. That, when we combine the real numbers with imaginary numbers, those are known as complex numbers. And for those of you going into construction, going into electronic field, or computing or whatever that may be, you're going to be using a lot of imaginary and complex numbers, because that's what's needed for electricity, that's what's needed for programming and such. So let me show you a complex number. Ready? Here it goes. Let me scoot this up a little bit. There it is. Okay, writing utensils down, look up to the screen. I'm going to write a complex number. Now, the reason I made this tool like this, because it's easy to see that we have real numbers on the left, imaginary on the right, and if we add both of them or subtract both of them, they become a complex. So watch. I'm going to pick a real number. I'm going to take a wild guess of a number. What would be a guess that I take? 23, Michael Jordan. Is this a real number? I'm going to add an imaginary number. The imaginary number that I'm thinking about is 4I. Well, guess what? Students, complex numbers, students. Copy that, please. You're like, that's it? That's it. A complex number has a real number, and it has an imaginary number. Let me give you another one. -5 plus 7I. Is that a complex? Yeah, because it's a real and an imaginary together. Let me show you another one. How about 3 minus 9I? Is that a complex? Yes, because it's a real, and now I subtracted an imaginary. So you can either add or subtract. So with that said, you make up one complex number of your own. Do that right now. All right. Share with your neighbor your complex number to make sure that they understood it. All right. What'd you get, Mariah? What's yours?
5 plus, wait, yeah, 5 plus 3I.
3I. Hands, if you agree with that? Yeah, that is correct. So hopefully you start seeing where we're headed, right? We started with real numbers. This is what we did prior to Algebra 2, which is Algebra 1 and geometry. Used a lot of real numbers, but now for Algebra 2, we're getting into the imaginary and complex. Good intro? All right, let's move on. Here we go. So one thing I do want to talk about before we fill out the Freire model and we get into algebraic expressions, I do want to talk about numerical expressions, okay? But before I do that, let me cover a couple properties that I want your noodle to prep for. And those of you that were with me, you're going to see how this is very familiar. Don't copy this, just pay attention. Write your utensils down, look up to the screen. One property that I'm going to have your noodle doing right now is called the additive inverse property. And the title says it all. Additive, which means you add, inverse. So you're adding inverses. What does that look like? Like this. A number and its inverse add up to 0. With numbers, 7 plus negative 7 is 0. Negative 15 plus 15 is 0. A negative 2500 and 2500 is 0. We've used that property in the past. Maybe they named it differently. I named it 0 pairs. So remember 0 pairs, some of you? You're like, faintly, Mr. Q. Okay. We're going to be using this today and for the next week for polynomials. The second property that I want to address is this one, the identity property of addition. Identity being that it identifies the same number at the end, and it looks like this. A number plus 0 gives me the same number. That's why it's called identity. It identifies itself. There it is. A number plus 0 is that number. With number, it looks like this. A number 7 plus 0 is what? Number 7. Negative 10 plus 0 is negative 10. And 1,000 plus 0 is 1,000. Okay? So we're going to be focusing on those two properties, but in the scope of numerical expressions. Now, I'm starting you off slow, so like that we can ease into what we're going to be covering today. Okay? So where you're at on your Freire model, and let's see, do you have space underneath the Freire model? Yeah. So on the Cornell notes, the Freire model is that one, the box. Yes? You have space underneath, yes? Yeah. I want you to write numerical expressions. And we're going to start slow using those properties that I just mentioned. So let's start with example 1Q. Example 1Q. So let's see it in action. Here we go. 9 plus negative 9. Everyone? 0. Okay. Example 1 mega Q. How about negative 12 plus 12? 0. You nice? Yes, 0. So do you see the property there, the identity, the additive inverse property? Yes? Okay, now I'm going to use the other property that I mentioned, and your noodle's going to do something right now. Here you go. Example 1 super Q. 10 plus negative 9. Now before you answer it, write your utensils down, look up really quick. Let me clarify your thoughts. Now, this looks almost like this. Is that correct? So this is what I want you to start thinking. Whenever you end up with an expression, the first thing I want you to do is scan it and to see if there's addition throughout. Is there addition throughout? Yes. The second thing you need to scan for is are there any 0 pairs? No. However, there's a slight 0 pair hidden in there. What do you mean, Mr. Q? Well, this negative 9 means a positive 9. Is that correct? So that means these 9 cancel how many of these? 9, and we're left with what? 1 positive. Does that make sense? Yes. Okay, that's using our properties and thinking about those two properties that we just mentioned. Let's do another one. Example 1 Shazam Q. Negative 14 plus 12. See if you can do that one by yourself, kind of like the one we just did. Don't say it out loud. All right, here goes the process. First thing we check for is addition. Does it have addition? Yes. All right, do we have any 0 pairs? Not obvious, but I think I can cancel these 12 with 12 of these. Is that correct? And that leaves us with how many of these? 2. Negative 2. So far, so good? All right, let's crank it up a notch. All right, here we go. Example, Power Ranger Q. All right, let's do negative 5 plus 9 plus negative 7. Okay, let's do this one together. Here we go. What is the first First thing I'm asking you to check, addition. Yes and yes. Are there any zero pairs? Not obvious. And for this one, we have now more numbers that are alike. What numbers are alike? -5 and -7, that becomes -12. Bring down whatever is left over, which is the +9, and this looks familiar, doesn't it? So, does this cancel 9 of those? Yes, and that leaves us with -3. See what we're doing? Yes? Okay, let's go to example 1. See, and JQ. There you go. All right, let's do 4 plus -3 plus 2 plus -4. See if you can do that by yourself. All right, so here goes the process. What is the first thing we check for? Addition, yes, 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 and yes. Okay. What is the second thing we check for? Zero pairs. Do you see any zero pairs? The 4 and the -4. Yes. And that leaves us with just these two. So what do you see? Well, 2 of these, Mr. Q, cancel 2 of those, and that leaves us with -1. So far, look good, yes? All right, show me where the fingers talking through you are so far up to right there. 5, 4, 5, 5, 5, 4. Yes? Okay. So this has been only numerical expressions just with addition. And you're saying, how about subtraction, Mr. Q? Yeah, let's go. Copy this. Example 1.
Should we write in the summary box?
Yeah, you can write in there. That's fine. 1. Let's see, you got, oh yeah, Star Wars Q. There you go. All right. So we got -6 minus -8. Just copy it. Let me go over something really quick. I know some of you already got this, but I just want to make sure I'm covering some of the things I want you to be keeping in your noodle. Okay? All right, writing utensils down, look up to the screen. Let's go through the process. Check for addition. No, Mr. Q, we have subtraction now. All right, so here goes the process whenever you come up with two numbers that are subtraction. The first thing, we rewrite the first one exactly the same. The subtraction sign, we change it to addition because we've been doing addition, yes? And the second number, we take the opposite of that number. What is the opposite of -8? +8. Does this look familiar? Yes, so 6 of these cancel 6 of those, and that leaves us with 2. Copy that, please. All right, example 1, Power Rangers Q. See if you can do this one by yourself. 7 minus, parentheses, -3. All right. Once again, check for addition, but we don't have addition, we have subtraction. 7 stays the same. This changes to addition, and the opposite of -3 is 3. And what is 7 plus 3? That is 10. Hands if you got that. You got this, yes? All right. Now, guys, all of these I mentioned earlier that they are what kind of numbers, what kind of expressions? Numerical expressions. But I want you to pay close attention and think a little bit outside of the skill that we're doing, look at the components. What do you see that all of them have? What do all of these numerical expressions have? Look at them. Talk it over to your neighbor. What do all these expressions have? So one thing that I hear, the first thing I heard is numbers. Is that obvious? And operations. Do you guys see that? Does it have anything else? And notice that I used arrows. Why? Because we're not solving anything. We're simplifying it. Does that make sense? So try and switch that in your noodles. Those of you that are used to the equal thing, try and switch that so like that you don't get confused when we get to the bigger functions that we're going to get to. Does that make sense? All right. So now that we're clear with numerical expressions, so think about it, numerical expressions, numbers, and operations. Now we're going to fill out our FAIR model. Let's go to algebraic expressions. Here we go. What are algebraic expressions? Algebraic expressions are, fill this in, expressions that contain variables, constants, and the constants are basically numbers and operations. Expressions that contain variables, constants, which are numbers, and operations. Expressions that contain variables, constants, which are numbers, and operations. So you're writing it down and you're thinking, okay, so algebraic expressions contain variables, okay, constant, which are numbers, and operations. That means it's pretty close to numerical expressions, is that correct? So the only thing that this one has that the other ones didn't is a what? A variable. That is correct. That's why they're known as algebraic. Let me give you an example. X plus 3. Does it have a variable? Yes. Does it have a constant? Yes. Does it have an operation? Yes. Copy this next one. M minus 7. This one, 2 times y. And this one, k divided by 5. All of these are examples of algebraic expressions. Pretty straightforward, right? Okay. So now that we know what algebraic expressions are, if these are algebraic expressions, why are these not? Don't copy it yet. Just look at them. Why are these not algebraic expressions? We have x plus 3 equals to 10, y equals to 3x minus 2, 2 times y greater than 12, and 2x greater than or equal to y minus 3. Talk it over with your neighbor, let them know why these are not algebraic expressions. All right, let's see, Jesse, why do you think these are not algebraic expressions? Yeah, there's equal signs and inequality symbols. So what does that mean, Mr. Q, that these we can solve? Can we solve these? No, those are only simplified. Does that make sense, though? All right, so copy those, please, non-examples. All right, so as you're copying that, if I was to ask you to take a picture of this and send it to your BFF or post it on your social media, whatever it is you use, WhatsApp or Insta or whatever it is you use, what would you hashtag this picture? What makes algebraic expressions algebraic expressions? Hashtag what? Yeah. Hashtag simplify. Thank you. Another one. Hashtag no equal signs. Yes. What else? One more. Yeah. Hashtag cannot be solved. That is correct. Guys, and that's how we're going to be filling in. Every time that we come to a new concept, we fill this in to understand the concept before we do any other work. Does that make sense? All right, so some of you fingers how come through you are understanding what algebraic expressions look like. 4 5s, 4 5, 5 5 5 5s. Okay. Now that we know what they look like, let's get to work. Let's go. So in the back, underneath the real number and all that, you have space. Do you have space there? No? Okay, then on another page, that's fine. I want you to write example 2Q. Example 2Q. We're going to start off slow, and you're going to see how everything that we did earlier is going to apply to this. Here we go. Yeah, that's fine. Negative 5x plus 9x. Let's do this one together. What is the first thing I ask you to check? Addition. Yes, it's there. Okay. Second thing. 0 pairs. No. Okay. Third. Like terms. Do we have things that look alike? Yeah, they're both x's. So I'm going to write x because I'm going to combine them. I'm going to bring down the x. There it is. And now I just focus on the numbers. 5 of these can cancel 5 of those. Is that correct? And that leaves us with 4. Let's do another one. Example 2 super cube. Let's do 12y plus parentheses negative 5y. See if you can answer that by yourself. All right, check with your neighbor, see what they got. All right, 7y, is that correct? All right. So let's add more steps to that. Let's do example 2 mega cube. All right, let's crank it up a notch. We got 4a plus 6 plus negative 7a plus negative 4. All right. What do we check for first? Addition. What? Time flies when you're having algebra 2. Let's see. Like terms, A. 4 of these cancel 4 of those. That leaves us with negative 3. In our constants, we have 6 and negative 4. 4 of these cancel 4 of those. That leaves us with plus 2. And have you got that? Yeah. Have a good one, guys. Enjoy your home play. I'll pick up packets tomorrow. Enjoy. Bye. I'll pick it up tomorrow.